I'd like to show you one of the sample artwork. This is the Jaguar XJS V12. This car has been running with a 5.3 liter V12 engine. The engine alone weighs about 950 pounds. Our students removed the engine and we are about to finish converting this gas power car into electric. This is a long process, but by doing so our students learn the basic, the principle and the advanced technology how to convert a gasoline into electric. I will take a few moments to introduce you the car. By removing the 5.3 liter, we have to put in sufficient weight underneath the hood. Underneath the hood, the car used to have about 1,000 pounds of engine plus the transmissions and support to accessories. We will replace the 5.3 liter V12 by a large AC induction motor. This motor weighs about 375 pounds. It has the average of about 95 kilowatts, the peak about 300 horsepower. This enables to drive the vehicle as fast as about 100 miles per hour. To power the car, we're going to depend on the lithium-ion battery pack. This car has a total of 92 lithium-ion battery cells. Each cell gives 90 amp-hour at 3.6 volts. So total voltage of this vehicle about 324 volt DC. Since the battery is DC volt, we need to convert the DC direct current into the AC to power the motor. So we're going to have a system controller which also happens to be an inverter. So we invert the DC energy into AC current energy, enable us to run the AC motor. In addition to that, we also developed a system that enables the car have full air conditioning, power steering, and power packs without depend on the 12 volt voltage. This is the AC induction motor. It's capable to give about 300 horsepower. Okay, the peak is about 95 kilowatts. This motor is connected with the transmission through the adapter. This is the air conditioning compressor, and it powered by the pulley. When we turn on the electric motor, the pulley will rotate and power the compressor, enable us to generate a very good air conditioning. This is the fan for the motor. This is the air cooling fan, because after you run many miles, the motor needs to be constantly cool with the flow of air. And this is the radiator. This radiator will pump cool liquid to the controller. The controller actually will be shown later on. The controller normally very hot after running many miles, so we need constantly cool with the liquid cool systems. And the front is the condenser for the air conditioning. This is the alternator. Like a typical internal combustion engine car, the alternator will be the place to generate electricity when the motor rotates. I'd like to show you, we have two battery packs. The first one, the front, this consists of 26 cells of lithium-ion iron phosphate. Each cell has 90 mAh at 3.6 volts. I will connect them in series. This small battery pack will be connected with a larger lithium-ion battery pack in the trunk of the car. Okay, with a total about 29 kilowatt hour, we can power this vehicle more than 120 miles between charges. Considering the fact that this is a very heavy vehicle, weight about 4,000 pounds, we'll pick up we choose the Jaguar XJS because number one, it's a very well-built car, a relatively full-size, heavy, and beautiful car. If we can convert a heavy car like the Jaguar XJS, virtually we can convert any car you can think of, provided we have enough space. And with the basics drivetrain, we can put in the AC electric motor powered by the battery pack, and with the AC controller we can actually manage the entire systems. This vehicle also have the battery management systems, enable us to monitor the state of charge of each individual cell of the battery pack, so we can tell how it works and the performance of each of the cells. And we also check the instant current, the voltage, but also state of health of the battery pack as well.